Can, huh? Okay, let's carry on. Okay. One reminder also, your attendance don't sign for your friend. If your friend not here, let him be. Don't try. Don't sign because CET very particular. Okay, don't sign for your friend, please. Right. Now a couple of more slides, then we are quite coming to an end later. Couple of more slides. Okay, so please bear with me. Now for signal processing, right? As I say, we do look at things later in more detail. This is because it's topic 5 is an introductory part. Later on we will do detail. In fact, you can look at your notes. The later part got a lot of calculation, so don't get worried. Oh, this one got no calculation. How to study? I'm sure you have that concern. But the calculation later coming already. Okay, later part when we talk about the filter, amplifier. Okay, there are some calculations. Okay, so these are some of the typical operations for signal processing. We will talk about filtering, amplifier, okay, and so on. Okay, but in this course, right? In this course, the main two focus is filtering and amplifier only. The rest we will not touch. No time. The scope too big. Oh, in fact, sensor instrument, you go to university, you can study one solid course on that. Oh, that one cannot finish. Very xiong. One solid subject. 2 to 3 modules. Xiong one. Okay. Now, very quickly, we talk about filters. There you see, we will be coming to that filters, right? Okay, we talk about filters. Okay, we talk about things like passive filters and also active ones. Coming to that. Okay. Now for passive filters, you may have heard about it, right? Filters are things like they use resistors, inductors, and capacitors. Passive because why? Why we say passive? Yeah, correct. Again, the same term. Passive means that the component itself is passive. No need power supply to work, right? I put a RC resistor, capacitor. Can you make a filter? No? You don't realize? This is passive, right? Now, active ones are ones we come with. You all know op-amp, right? Operation amplifier. We will come to that. Okay. So let's start with the first segment. What we call the active filters. Okay, filters. Now, basically a filter, if you know, I think you can guess what is a filter. A filter is something that can allow certain things to pass through, right? Usually we talk about waveform, signal. Signal can pass through or not pass through. Okay, so a filter is a circuit that can control, okay, whether the frequency or the signal can go through or not go through. Okay, filter. Okay. Now filter design also very important in things like telecommunication, right? You know what I mean? Like for example, you know those pulleys one? Those pulleys, I'm not in the police force, we all in army. I know my some last time friends in the police force, right? They carry the, what is that? Walkie-talkie. The walkie-talkie is island-wide one, no? Yes. You all know, You know the Bukit Timah hill? You see those antenna up there? You know, that one is for police one, no? You all know? I think you all know, that one is a police antenna, but the police one is encrypted one. The signal is encrypted. Encrypted means they code it, right? It means you cannot unscramble the signal. It's coded one. Okay, so those kind of things, filtering very important. They need to filter the signal. Alright. So for this case, frequency that can pass through is called a pass band. Okay, pass band signal. Okay, now I'm not sure how much you know about filters. I'm not sure your level of understanding on filters, but I will take it that you don't know anything. Let's make it from ground level, ground zero. Okay, we will take it up from there. Okay, now filters. Now basically, these are what we call the filter responses. Okay, let me put it here. Okay, now, so what is a filter? Okay, very simply, right? What a filter is this. Now, to me, or to you, you can consider like, let's say if I have a black box, I would like to use this analogy, black box. This is a filter, right? Don't care what is the circuit inside. Okay, let's talk about it simply. Now, if I have a signal, okay, if I say that this is a filter, right? Okay, maybe, okay, this one say, okay, maybe you can make it very simple for you. Let's say, of course, a little bit low lah, over here. Now, if I say if I have a filter which has a certain range, every filter has a certain specification. So I say that this filter, right, has a certain range of frequency that you can operate. Okay, so if I put a signal, let's see if I put a waveform, I call it a sine wave. Okay, this signal has a frequency of 1 kHz. Pass it to this filter, but I tell you this filter got this range. And what's the output?
50 Hz to 200.
So what is the output?
50 Hz to 200.
Yeah, 50. You see 50 to 200. What is the output?
0 to 50.
0. Huh? 0, right? Why? Why is it 0? Because what is this thing here?
1K.
1K. What is this? 50 to 200. Is it? Are you in the range?
No.
No. So what happened? 0. Signal cannot go through. Right? Because you're not in the specification range of the filter, right? Okay, so this kind of thing, when you have from a lower range to a higher, this is called a band pass filter. Band pass. Why band pass? Because it has a band. Okay, between the lower range to the higher range. Okay, it's called a band pass filter. So sometimes they call it short form BPF. Yeah, if you want to write it down. Okay, band pass filter. Yeah, band pass filter. Bandwidth is different. Okay, of course. It has a certain bandwidth. If I ask you what is bandwidth, okay, good question. Since you all bring up this term, what is bandwidth?
200.
Very good. What is bandwidth? Bandwidth is the range. That means you take the upper minus the lower, right? So it's 200 Hz minus 50. So in this case, the bandwidth is 150. Okay? You get it? Okay, but this is the band pass. Okay, band pass, a range. But this is the bandwidth. Okay, I write it down. VW, short form. But if you want to write it in words, it will be this thing called the bandwidth. Okay, quite common. This thing sometimes you will hear this in bandwidth. So the bandwidth, you have to take the upper range minus the lower range. So this is the bandwidth. Okay, got it? Now there are mainly there are 3 types of filter that we want to cover in this course. Low pass filter, high pass filter, and then the other one is the band pass. Okay, maybe you want to write it down for somewhere in your notes, but these are the 3 main filters that we will be covering in this course. Okay, yeah. Band stop we are not touching, but we just show you it, but we will not teach you. But the main thing is the first 1, 2, and the 4th one. This one, no. This one, if you want, you can just write off. Okay, yeah, these 3 filters. In the exam or in the common test, no, not common test, sorry, mainly in the exam, mainly in the. But after Mr. Chan's common test, later part, I have a short quiz for you. That may be covered in the quiz. Okay, but in the exam, yes. Okay, it will be covered. Okay. So any questions so far? Low pass, high pass. But we will explain more detail. Okay, but this is bandwidth. Okay. Now let me give you another. You're okay with this? Can I write off? Take it off? Can I? Okay. Now if I say, okay, let me give you an example. Okay, if I have a low pass filter. Again, okay, if I tell you low pass right now, if you look at this, this is called the filter response curve. Okay, now if I have something what we call the low pass filter, okay, low pass filter. Now what I have here is what we call the filter response. Okay, now usually this one is in decibel dB. This is like the gain. The filter. Now what happens is this. Okay. Now if you have a low pass filter like this, now usually the signal will like that and flow off. Now this is frequency. Okay. This on this axis, the horizontal axis is the frequency. Over here is the so-called the gain of the filter, usually in decibel, dB. Okay. Now, so very quickly, now what happens is this. Now for low pass filter, the profile is like that. So there is this thing called the cutoff frequency, FC. Okay, FC. So what happens is this. This FC is the frequency that you can pass from 0 Hz all the way to FC. Anything frequency starting from 0 Hz, okay, can go until FC. FC is the cutoff frequency. Okay, I'll just finish one more last one, then we are kind of done. Okay, so anything for a low pass filter, anything from 0 Hz all the way until the cutoff frequency, this band of frequency can pass through. That is called low pass filter. Okay, you understand? So if I tell you that this low pass filter has a cutoff frequency of say 1 kHz, what does it mean? If I say that the cutoff frequency of this one is 1 kHz, right? What does it mean? That means anything from 0 Hz all the way until 1K, the signal can pass through. Okay, anything above 1K will be cut off. Okay, that's the idea. Okay, understand? So that is low power, low power. Okay, one final one. Okay, before we end the evening. Okay, is this thing called the high pass. Okay, we will do the band pass in the next lesson. Now for high pass filter, HPF short form. Okay, high pass filter. Okay, what does it do? The waveform or the profile looks like this. Okay, it has a certain cutoff as well. Okay, but what does it do? For the high pass filter, okay, the cutoff frequency may be, okay, let's give the same example, 1 kHz, for example. It means that if you are here, let's say if I'm 50 Hz, can the signal pass through? No. Okay, very obvious. Because anything here between 0 to the cutoff, this band here, frequency not allowed to pass through. Okay? So frequency above the FC will be allowed to pass through. Okay? But of course, what is the upper end? Did they state the upper end frequency? Technically or theoretically, the frequency is infinity. It can keep going, because it's high pass. High pass filter. Any frequency after the cutoff can go through. Okay, so theoretically is that can go to infinity, but there's no such thing. Nothing infinity can go very, very far. Anything below here, cut off. So this is what we call the cutoff range. This part over here is the cutoff range. It means the signal cannot, this part nothing, no signal. Here, okay. Here is the good. Here is the okay part. From here to here, okay. And keep going and keep going. Okay, I think I'll stop here. You all please make sure you sign your attendance. Attendance, okay? Then I'll upload the recording. Where's the attendance folder?